Okay, today I am going to discuss a question given under the lesson probability. For that, I have selected 2018 past paper. So this question was given in part A. Let A and B are two events in a sample space S with the usual notation PA equals 1/3, PB equals 1/4, PA intersect B is 1/6. We have to find PA gives B dash. So this is from conditional probability theory. So conditional probability, if they say P or probability of A gives B, that is equivalent to probability of A intersect B over probability of B. So we have to consider the intersection of these two events and we have to divide that by probability of second letter PB. The meaning of A gives B is already event B has occurred and we have to consider the probability of event A occurring. The question is probability of A gives B dash. According to our conditional probability theory, we know it is the intersection of these two events, A intersect B dash divided by PB dash. They have not given this data, A dash, A intersect B dash. So we have to consider a Venn diagram and find the value for this. Let's say in the sample space we have two events, A and B. A intersect with B dash is actually this region. B dash is except B and it should intersect with A. So this is the region. Then from set theory, I can say A intersect B dash is equivalent to A probability of A minus, I have to deduct A intersect B, this intersection. So probability of A intersect B dash is same as probability of A minus probability of A intersect B. So this is a theory that you should remember under probability. This information is given. Probability of A is 1/3, A intersect B is 1/6. So we can get the answer, it is 1/6. Now I can substitute here 1/6 divided by probability of B dash. From your O-level knowledge, you know probability of a complement of an event is equivalent to 1 minus probability of the event. So probability of event B is 1/4. Probability of complement of that event is 1 minus 1/4, which is 3/4. So I have to divide this by 3/4. Then it is 2/9. Second one, we have to calculate the probability of A dash intersect B dash. To find this, again I have to consider a Venn diagram. Inside this sample space we have two events, A and B. A dash is this region except A. B dash is this region except B. Intersection of these will be this outside region of the sample space. So I can take this region or the probability of this region by considering A union B dash complement of A union B, because you know A union B is this region enclosed by both events. Complement is outside that. So we can find A union B from this relationship from your O-level knowledge. It is probability of A plus probability of B minus probability of intersection. One third plus 1/4 minus 1/6. This is the probability of A union B. Complement of that is 1 minus 5/12, which is 7/12. So probability of A dash intersect B dash is equivalent to probability of A union B whole thing dash, which is 7/12. At last they ask in the probability of B dash gives A dash. From conditional probability theory we know B dash gives A dash is equivalent to probability of B dash intersect A dash over probability of second event, which is A dash. Now we have already calculated probability of A dash intersect B dash. B dash intersect A dash is similar to we can use this theory. Same two events, we have to consider their intersection. So A dash intersect B dash is same as B dash intersect A dash, which is 7/12 divided by probability of complement of A. A is 1/3, complement is 2/3. Then we have 7/12 multiplied by 3/2, which is 7/8. Typically they are giving this kind of a question for part A, where some informations are given and we have to find these kind of conditional probabilities. So these are the relationships you must memorize. And also by using Venn diagrams, sample spaces, you can derive these kind of relationships. I hope you understood what I discussed from this video under probability. Thank you.